right, morning everybody, welcome to week 4. Means we're a third of the way through certification and we're getting stronger. Had a bit of a dip previous week. This week actually it's 17 people, right, from the 14 from the previous week. So you guys did want to stay strong. And I think from the average, if the average went up to 71%, I think the first 2 weeks, just getting into the whole JPA thing, it was difficult. I mean, the first 2 weeks, the questions, although they are easy in the bigger scheme of things of JPA, if you're new to JPA or even to certifications, I think they were really difficult. But it gets easier now. I think once you get into it, it should be fine. I think you also see just from the average, it's gone to 71%. We actually had 3 people who got 100%. I think it's 3 new people as well. I think it's like each week, it's not the same people that hit it out of the park every week.
We've had a big meal.
Well, actually, I need to go and see when these people write. Maybe you can have go and write the certification review before lunch. Otherwise, you go puppy. You can't. Once you go puppy, you can't write the certification exam. All right. So we usually do the bottom 3. I'm just going to do the bottom 2 because there's 4 other questions with the same average of 70%, and that means you can do like half of the questions, and then you might as well do all of them, and I don't want to do all of them. So we're just going to do the bottom 2. Wasn't really too much different here. Let's go out this question. The first one, the bottom of the one that most people got wrong and less than half, is you're using extended scoped entity manager, which of the following statements are correct. And I think if you looked at the review questions, there's a lot of stuff between is it extended or is it an application scope or is it a normal application one, is it container or not. And whenever you see sort of looking at the question around these entity managers, first you need to go and identify are we looking at container application managed and is it transaction scope or extended. And then from there you should already sort of zone in like, well, these are the only correct things that they can be. So looking at extended scope entity manager, so that'll be either running as a container managed, which will mean it must be an estate list bean, or it'll be an application managed in the SE application, because that can only be extended scope. So call persist, remove operations, entity manager will throw an exception. I don't know why. Nope. It will maintain its reference to entity objects even after transactions committed, and that's specifically what the entity scope manager is for. It's maintaining that thing. So that's the correct answer. You must be using entity manager in a Java SE environment. Not true. So it's the only one you can use in an SE environment, but you can't use container. You can only use application scoped application scope entity manager. So that's not true. And then the managed entities of an entity manager will become detached when transactions roll back. So that doesn't actually matter which type of transaction you're using or which type of entity manager. If you roll anything back, they get detached. So this is just one of those questions we just need to know it. And I think when you're studying for the certification exam, it's one of those things where you've got this little block and you sort of almost have a comparison between application and container managed and transaction scope. And you should be able to say, well, if it's container managed, this is what's going to happen. And you'll see from the questions, especially if you do the mock exams, what you need to know from that. So I think this was just, you just needed to know it. And the other one is question 9. If I look at this, let's double check. 9, yeah. And this one, so I think this is probably the type of questions you can expect where they're not going to tell you it's a container managed or application managed entity manager. They're just going to give you some code. You need to decide what it is. So looking at the code, the fact that we've got persistent context being injected there already tells you it's a container managed. There's no other way. It can't be anything else. So anything that's got anything to do with application managed is already out of the door. They don't say what type of bean this is, but so first of all, looking at the first 2, is it container or application? Is container. The only time this could be application managed is if it was actually an SE type code, and they'll probably tell you it's got a main function or it's not a container, or if this thing had the persistence unit injection happening, where you can actually go and you can see from that you're actually creating the one. And the fact that it's container managed there means that it can only be the JTA. Could be a JTA resource depending on resources local, JTA entry manager. What? Let's see. So this will be a JTA entry manager. So container managed can only be JTA because it's a container. So the only way you can get it anything else other than JTA is if it's application managed inside a container. You need to use a resource local and then the wheels have come off if you kind of go in that route. So the two bottom questions are both sort of based around what's the difference between entity and a container and application managed entity managers. And there wasn't a lot about the operations and this and that. I think there was a question, one of the other ones was, what type of operations can you do? Can you persist it? If you've removed something and you try and merge it again, what happens? That type of stuff. So, but I think you guys are getting the drift of the type of question. So as we're going through this stuff and as you're going through the chapter, always think about, this looks like it's something tricky and this might be something they're going to ask questions about. So think about the type of questions they might be asking about it. And that's sort of also coming back to coding. So sort of thinking about what happens if this happens? What happens if I do that? And sort of thinking about that type of questions they could ask and then trying it out in code is probably the best way to sort of get this down and understanding what's happening. All right, so today we're looking at entity relationships. I think a lot of the stuff, especially this first few objectives of JPA, it's sort of like a chicken and egg type thing, because you're talking about one object, like this, we're talking about entity managers, but then you need to know about relationships. But before you know the entity manager, you can't really do much with entities, relationships, anything. So we've got another 2 weeks, and then everything will just fall in place, and it will just be together. We've looked at entity managers and entities and relationships and collections and all that type of things. So this week we're looking at relationships and the different ones I've got there, and also just some of the cascading stuff. So last week with the entity manager, there was some cascading stuff, but I didn't cover it, and I don't think there were questions about it. You'll need to know it. So if you read about that last week, then you don't have to read about it again this week. But if you didn't pay much attention to it last week, just go back to the previous chapter, which was last entity manager, was chapter 6, I think, and just go and read those little bits about cascading updates. All right, so relationships and the different concepts around relationships is, we're first going to look at some of the concepts before we start talking about it. So the first one is the relationship types, and then you've got your normal database relational sort of relations there, one-to-one, one-to-many, many-to-one, many-to-many. And if you've worked with any type of database stuff before, this should be pretty normal. The only other thing that comes in with JPA is they talk about directionalities, and we'll cover that as one of the concepts now. So the first thing is around the different roles in the relationship, as they probably relate more in a way to the JPA. And that's that you've got an owning side of a relationship and an inverse side. So almost like a parent-child relationship. And the owning side is the one that controls the relationship. So, and if this was a marriage, it'll be the wife. So it can be the owning side or the wife, because it controls the relationship. I see there's a lot of smiles around here.
Hate smiles.
So that sort of controls the relationship, and then of course the inverse is the other side, or the male side of the relationship. And sort of in terms of the database setup, the owning side will usually be the one that has the foreign key. So in the little example at the bottom here, you've got the employee and the department, and the employee has got a foreign key to the department, so the employee is the owning side. And I think looking at relationships, and especially looking at the certification exam, when you're reading the stuff, sort of maybe draw out a little OR diagram, a relational diagram, and just sort of see, this is the way things fit, and this is the way it flows. It might make a bit more sense doing it that way. And the other bit, which is specifically to the ORM sort of scope, is the directionality, and that's other different entities, if they know about each other or not in the relationship. So you get bidirectional, which means both sides of the relationship know about each other. So employees know which departments they belong to, and departments know which employees are in them. So you can actually, in your code, go from the one to the other, it doesn't matter. And then you get unidirectional, which means only the one side of it knows about it. So in relationship, that'll be like a stalker relationship. So from here, the employee knows which department it's in, but the department doesn't know which employees are in it. And this is sort of a domain-driven design type thing, where you need to decide, listen, here, does it actually matter from a business point of view, from the way my objects are looking at each other, do the departments need to know which employees are in them? From a database point of view, it doesn't really make a difference. If you've got an owning side and an inverse side, one will have a primary key and one will not. And the other bit is just cardinality and ordinality. So cardinality is the sort of one-to-many. So if it's going to be one on one side or many on the other side, and that many sides usually represented by a little star. So you can see at the bottom the employee in departments. There can be a lot of employees, but employee can only have 0 to 1 departments. And the 0 to 1 is what they call ordinality. And that's sort of just saying that the other side relationship needs to be mandatory. So in the little description at the bottom here, an employee can or cannot belong, may or may not belong to a department, doesn't matter. So I don't know if you don't belong to a department, you might be a casual worker, maybe they will pick you up at Builder's Warehouse on the Saturday. I need you to come and, oh, you're a developer? Yes, I am. Okay, come. I need you to come and do some stuff here. Okay, so let's see, there's no questions or anything so far. All right, so getting into the different relationship types, and there's a lot of sort of overlap between the different relationship types, and there's not too many rules around, well, if it's a one-to-one or a many-to-many or many-to-one, too many things are different between them. There's a lot of overlap, so sort of if you know the basic concept, you can almost apply them to all of them. So the first one we're looking at is the one-to-many and many-to-one relationships, so they go hand in hand. And on that, you can use the different annotations of XML. So for a many-to-one, use the @many-to-one annotation on the class, or you can use a many-to-one element in XML. And then the opposite side, so if you've got a bidirectional one where both sides, so the employee and the let's go next. So with the employee and department both need to know about each other. Then one side will be a many-to-one, and the other side will be the one-to-many side. So that makes it bidirectional. If you don't have the many-to-one side on the department and only an employee in your department will be unidirectional, then you have the many-to-one on the employee side. So the important things around here is that the many side needs to be the owning side of it normally, and that'll have the foreign key on there. So if you don't define a specific foreign key name, if you just say, listen here, Mr. Provider, go and define it for me, it'll usually use the inverse entity's name plus the inverse entity's primary key as the name. So an example here, because it's department ID, it'll be a foreign key. If you don't tell the JPA provider, it'll be department _ ID, will be automatically created for you. But if you connect into an existing database and you need to actually specify what that foreign key column is, you can use the joint column annotation. And that's you're pretty much going to tell it, listen, you've got a foreign key and this is the name of that field. That's the foreign key. Then the other bit around the one-to-many side. So on the one-to-many side, like we've got you on the department side, you have to go and specify the map by little attribute there, and that sort of says in the other entity, and the owning entity, this is the field that that's sort of linking back to me. So if you look back at our employee class, you've got a department field here, or if you're using properties, department property, and you'll sort of say this is what's mapped back to it. And the reason for doing that is if you don't specify the mapped by department here, or you don't specify your joint column on that side, if you don't do the one, so pretty much you're sort of specifying a unidirectional type relationship. Instead of creating two tables with a foreign key like in your employee, it'll actually create like a table in between them. Same way the many-to-many does. And we look at joint tables in the next one. So if you don't specify one-to-many on the other side, and you don't specify a joint column on that side, so you need to, so pretty much if you don't specify foreign key, then you put it like that. So if you don't specify a joint column, or you don't specify a map by, so one of the two needs to be specified. It's going to be unidirectional, and that means it's going to create like a funny little joint table between them. And that's it. So from a code point of view, I'll do a quick little demo of this, but I said pretty simple. Find a many-to-one and a joint column if their name is different, or one-to-many on the other side with your map by attribute. So generally you'll define that nothing's going to tell you, if you don't specify the map by, it's not going to complain, it's not going to error, but it probably won't generate the type of database you're looking for. And then if you're doing this in XML, as part of your attributes for your entity, you're going to specify your many-to-one or one-to-many, and then you just specify a joint column and map by there. The other one is a one-to-one relationship, and so I haven't in my life, I haven't seen too many one-to-one relationships in a database, and this might be something that, from an object orientation point of view, it might make sense for you to have something like this, but from a DB point of view, it might not. But that's sort of where you need to decide, listen here, this is something you want to do or not. Because one-to-one is almost like you're taking one relational table and just splitting it in half. Because there's no other way for these things to relate to each other unless you've got some, I don't know, it's more an object orientation type relationship you're setting up there. So the main thing of that is, even though it's one-to-one, you still need an owning side, and the owning side will have the foreign key on it, so you can either use the join column again, or you can do the map by on the other side. So just looking at the code here, we've got an entity which is the employee, and that employee's got a parking space. So one employee, one parking space. And here, because the employee's got the join column on, and because the one-to-one's got the map by on it, the employee becomes the owning side of the relationship, and that gets the foreign key in it. And yeah, that's it. So, and once again, this can also be unidirectional or bidirectional, depending on if you put the one-to-one on both sides, both entities, or just on the one side of the entity. Then in the XML, once again, just going to add as an attribute. And then one of the interesting ones that, if you really want to mess yourself around, the many-to-many relationship.
That's where most people get thoughts.
Yeah, so, I mean, there are situations where you probably can't avoid a many-to-many type relationship, but try and see if there isn't a different way around it, because it's always, when it comes to removing stuff and joining things up and, you know, is this thing related to that thing, it always becomes a bit of a mess when you have to do reporting and pull things in, because you're always going to have like a huge join on these tables, and you're always going to have to pull in a third table to get any information out of it anyway. So they are, I'm not saying don't use it, but they sort of be one of, not the first card you pull out of the deck. It should be like, okay, let me see if there's some other way of doing it. So the main thing with many-to-many, like for one-to-one, you still need an owning side. So even on a many-to-many, if in business sense there isn't like an owning side, you still need to pick one. And there's no real reason for it, just when it comes to cascading. You usually cascade from the owning side down, so whichever side makes sense to have as the parent side, that's which one you'll mark as the owning side. Then doing a many-to-many is you're going to need, it just doesn't make sense. You can't have one table, you can't have two tables with an infinite amount of fields on both sides to have the many-to-many relationship. So you're always going to have a table in between them to map the two between them. So if you've got employees and projects, any amount of employees can belong to any amount of projects. Any amount of projects can have any amount of employees working on them. And for that, you're going to need sort of a table in between, and that's what they call a join table. And in terms of the JPA, the way you set that up is you've got a many-to-many on both sides. And once again, deciding which side is the inverse side, you're going to add the map by, so the other side makes it the owning side. And I think the join table doesn't matter which side you put it on. I don't necessarily think it, can't remember, I don't think it makes that the owning side. I'll just double check that. But you can add your join table on any side. So even if you don't specify a join table, JPA will still create it for you. So the only reason it's the same as with the foreign key on the one-to-many, many-to-one, and one-to-one type relationships, it's if you're working with a legacy database or there's a specific reason you want the names different, you can specify a join table. So you can specify the name of that table, the join column, which will be the owning sides column, and the inverse join column, which will be the inverse sides column. And you specify it like that. And then on your XML, same type of idea. Put your many-to-many on both sides, and you can specify your join table, and inverse columns and all that. So I'm actually going to I'm going to do a little demo and just show how the provider actually generates those tables depending on how we change the different types on there. And I've just got some rules for directionality. I've sort of mentioned all of them already. The map side, having an owning side, where the foreign key goes, and all that type of things. The other bit that you need to know about is we spoke about lazy and eager fetching in the second week. We were looking at entities. So at an entity level, lazy fetching one little single attribute doesn't make sense, like just the name or something like that. But when it comes to relationships, where you could have like a whole list of things, so let's say you've got a department that's got 1,000 employees in it, you don't necessarily want to go, if you get that department, also go and fetch all 1,000 employees from the database. So in that case, it makes sense to actually go and say, listen, I want to lazy load this specific relationship on there. So in that sense, it makes sense to do a lazy load. One thing again, though, as with the other eager loading, is just a hint to the provider. The provider will still decide, listen, I know better than you, Mr. Developer, and I'll decide if I want to load it or not. So it might cache it, or it might already be cached. So if it's cached, I'll just go and fetch it anyway because it's already there. And then on a bidirectional relationship, you can make one side lazy and one side eager, so you can do it that way as well. So if you're saying one side, so if we've got our employee and project type thing here, so you can make your employee side load the project's eager, but you might, and the project's not load the employee's eager. So you can set it that way around. And this is authenticated by a fetch perimeter on your, I didn't put a code snippet yet, but it'll be sort of on your code here, on your many-to-many, you'll sort of have a little fetch there, and that'll be equal to fetch pub.lazy, something like that. It'll be something like that that'll add on to it. I don't know if it's fetch type, it might be something different. We'll check now. But it'll be something like that, and you'll just pretty much saying, listen, whenever you go and get me, just go and fetch the rest of the data lazy.
I mean, what happens is that it triggers when one client actually pulls out, information, and you pull the whole database.
Yeah.
This is my main gripe with JPA, because people don't realize, they don't test it.
Yeah. Yeah, I did. I think I was already mentioning there's I think a lot of times people are kind of blind to the fact that JPA has actually got SQL running in the background, and there's a database in the background. And if you're not really sure what's happening, you might do a simple little, hey, get me this project, but because you've set your JPA entities up with a bunch of cascading refreshes there,
the database.
You pretty much get one project, but then that project goes and fetches every employee and every department of employees and every parking space, and after a while you've got like a 1 gig cache of entities but pulled up there. And I mean, that's also one of the reasons that people are kind of, I wouldn't say moving away from ORM, but they're scared of it. Yeah. And a lot of people have been burned by ORMs because of that. And it comes down to people not understanding what's actually happening in the background. They just, I'm putting an add entity on this. Cool, let's go.
Let's lazy load everything, and then one client clicks and takes down the whole database.
Yeah. Okay, so we're going to look at some relationships. So actually, I wanted to stick with Derby, but like Glassfish, it burned me in this instance. And it's more because running this stuff like in a test container like this, it runs as an embedded, and embedded can only have one connection to it.
No, but there's a way around that.
But then I was like, okay, let's do MySQL. So then we've got an example of using MySQL.
I'll show you afterwards how to do with Wildflower with
Wildflower
H2.
Yeah, no, but I don't want to. I want to do Tommy, and Tommy does embedded. So
Call it the best.
I know, I was like, please, Tommy, I want to have my cake and eat it. But Tommy came and said, "Here's your cake," and then Derby came and threw the cake in my face. So I actually went the MySQL route to get this set up. So it's no real difference here. So I'm just going to presentation mode. So there's no real difference here. The thing is just you set up your driver. The only thing I struggled with here was this sort of property is supposed to auto-create your database and your tables for you, but it's not auto-creating the database for me in MySQL. It sort of just says it's not there and then doesn't create it. So, and I was like, well, the JPA doesn't actually specify, that's not part of the specification. They don't really care, so I didn't care too much for that. So I just had to create the database myself.
It could be in your URL. Normally you have like a create new, or you give it
to
create new there.
I asked Stack Overflow and I don't know, maybe I was asking the question wrong. It's like, is it in the matrix where he sees the architect and you have to ask the questions correctly? No, with Derby you can say create true.
Yeah.
But yeah, I don't know. Maybe that's your homework. That's your homework. All right, so that's the only real thing. Otherwise, and then I'm using Hibernate again. So what I've got here is the same little Maven project archetype that we used previously. We've got our employee and department. I've just added parking space and project. We use there as well, so it goes and creates an employee. and projects. So normal, see if there's any employees. If there isn't, use the manager to create a department and an employee, and then just persist, and then that just writes to the database. The only thing I'm actually just doing is at the end, so I'm just printing out a list of employees and a list of projects. So I don't have to worry too much about that. So looking at our employee, I've got a few different relationships set up on it. So I've got a many-to-one. So being the many-to-one on the many side, this means the employee is the earning side. I've also specified a join column on here. So if I didn't specify the name, it would have made a department underscore employee underscore ID foreign key for me in my employee table. I've got a many-to-many data one as well with the projects. And this one I've made it sort of the different way around, that the employee is the inverse side. And then I've got a parking space here, which is a one-to-one relationship. So if I go and look at my department, which is the inverse of the relationship on the one-to-many, on the many-to-many, so this is the one-to-many side, and I've actually said mapped by department. So I'm telling it, listen here, your earning sides field is called department, that's where you link to. On my parking space, the many-to-many, specified this is mapped by, so it does the other thing for me. And on the project side, I actually didn't use any of the annotations. I actually put that in my ORM. So you can see I've got my entity class there, which is my project. And the attributes, I specified a many-to-many relationship to employees. And I've given it a join table as well, which I say I want to call the table proj_emp, because I'm back in the 1980s. And the join column and inverse column different as well. So if I didn't specify a name here for the join table, it would have made it employees, or the owning side will be project underscore employees, and it'll be project underscore ID employee and underscore ID for the different columns. So what I'm going to do is I'm just going to run this using Maven to compile and just execute that specific API test class. So you can see it's done, and all it's just done is printed those out. But we don't care about the printouts. We want to go and look at the structure. So there's no presentation mode on MySQL. I don't know if anybody knows about one, but there is none. So you might have to go and squint and see what happens here. So if we go and refresh that, so we've got tables. So we've got a department table, an employee table. We've got a department ID because that's what I've specified in my code. I want a department ID field there. We've got a proj_emp table. And there we've got a two columns, proj ID and emp ID. So that's what we wanted. Our parking space should just be a normal ID and the number of the parking space. And then on our employee table, we've got our parking space ID. Because I didn't specify a name there, it's going to use the field name or the entity name underscore primary key to create that for me. So that's quite, so I'm going to just change one thing here. So I'm going to drop this database and walk away. And I'm back. So we're going to recreate the database. Those people, it's like dropping the mic and then walking away. But I dropped the database. All right, so I've recreated the database. So what I'm going to do is, on my employee one here, I'm not going to specify a join column. So let's comment that out. And then on department, I'm also going to specify a map by. So the rule is that because I didn't specify a foreign key on the join column or map by on my one-to-many relationship, it's going to create a join table for me because I didn't specify, and that's the default behavior it's going to have. So if I just go back here, let's go and run it again. And you'll see what Hibernate does. It actually shows an error and says the table doesn't exist, but then it goes and creates it. So it's not it's an error, but it's not an error that's going to stop the process. So if I go and refresh this, you'll see we've now got a department employee table because I didn't specify it. So that's sort of what's going to happen if you don't specify a foreign key on there. All right, let's recreate this proper if we go on. I think the main thing is sort of taking these things and sort of playing around with and seeing does it happen, what's happening, how, and what and where and all that. Employee, well, that doesn't need to be back. All right. Any questions yet? All right, then last little bit around relationship is cascading operations. So by default, if you've got a relationship in your entity, and you say, Mr. Provider, please persist this entity for me, by default, it's not going to persist the entities that are related to it. So it's not going to cascade that same operation down to those entities. And that's sort of where the cascading comes in. You actually have to specify and say, listen here, when I persist my employee, I want you to persist my departments as well. So you have to say that it's going to cascade. And the way that works is that the provider will go and look and say, listen here, has this entity got any relationships? If it has a cascade attribute been defined on that specific entity, and then what type is it? So it can either be a persist, so whenever I persist the entity, persist my relationships as well, refresh, remove, merge, detach, and all. So if you don't want to specify all 5 of them, you can just say all, if you're going to use all of them. And then the same thing in your XML, you can also go and specify a cascade element on your relationship, and then go and say cascade all, cascade refresh, blah, 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 all that type of things. Cascade settings are unidirectional, so if you add it on the one side of the relationship, so if you just put it in the owning side, it'll always just cascade from the owning side. It's not going to by default then cascade from the inverse side as well. So if you want it from both ways, you have to put it on both sides. It almost sounds dirty. But most of the times, if you are going to have cascade operations, you're going to do it from the owning side, because that's why it's the owner who's going to decide when things happen and when things shouldn't happen. Doing it from the other side, yeah, you can maybe if you want to take shortcuts in coding for whatever reason, but most of the time you just put it on the owning side in any way. So looking at the different cascade options, the persist option just very much means that everything you're going to persist, you want to persist these relationships as well, and there probably isn't a reason ever you wouldn't want to do that. But if you're persisting the owning entity, not persisting the inverse as well, I don't know, you might have some weird rollback or some funny workflow that you might want to do it in, but otherwise...
Maybe your DBAs are asked if they are, they might not want you to lock the table.
Yeah, so there might be some locking. And so there'll be some exception for the rule for not having a cascade persist on there. One caveat with persist, though, is you can actually override the default cascading option on all entities in your persistence unit or your persistent context to persist. So that's the only one you can do it. So you can't do a default override on remove or something. So you can override them, but if you actually set up your defaults for your entire persistence unit, you can make the default cascading persist. So it means you don't have to go and specify in each relationship you do. That's the only one you can do it with. In the remove option, the remove is the only one you really need to be really careful with, because that's sort of one thing. The same way that you can go and fetch the entire database, you can also go and delete the entire database if you cascade remove. So that's sort of one of the things you need to be careful with. Like, you know, if I actually go and delete this employee, do I want to go and delete the parking space and the department he belongs to, and then that department has a cascade delete down on each employee, it goes with each employees, and so things can go horribly wrong. So the remove one is one you really need to be careful with. One other safe way to do this, there's an orphan remove attribute, orphan removal attribute on your relationship attribute, so a many-to-many or one-to-many attribute. You can actually have an orphan removal on there. So it means that if you've got a parent-child relationship where the child entity actually can't exist without the parent entity, it doesn't make sense, then you can say, well, listen here, this guy can't be on its own without being, so you can't have an orphan record in there. And there's quite a few databases that suffer from that. So if there wasn't proper integrity set up, then a lot of times you can delete, let's say something like the salaries for an employee. Let's say, so you've got a list of every time the salary got paid for the employee, so those salaries, so they say shouldn't exist without the employee. If the employees in there, the salaries don't make sense because it links back to the employee, and if the employees in there, then what are they? It's just money, you know what you do with money, just throw it away. So in that way, somebody might delete the employee because he hasn't worked for the company for 10 years, but now his salary records are stuck there, and they become orphans. So in that way, you can use that orphan removal attribute to say, okay, well, we don't want any orphans. If the salary doesn't have a parent, delete them. So the remove one is one you really need to be careful for, and generally, unless you're very certain of it, I wouldn't necessarily go and add and remove cascade on an entity. I'd rather go and manually remove it myself if I want to remove. Because also, how often you really want to delete something out of the database? In this day and age, there's a lot of stuff around auditing and all that type of things, and if you're going event sourcing and that type of stuff, so deleting things out of the database shouldn't really be happening anymore. Well, they do, but there should be other ways around it, because if you either roll back stuff or have auditing on there, then it's not going to work, especially enterprise type systems. And homegrown little system, yeah, go and delete it. Who cares? Then you've got merge and detach. Nothing really funny there. I think when it comes to merging, especially to merging this, understand the merging rules and what's going to happen. The same way that if the entity doesn't exist in the persistent context, it's going to actually create it. But if it does persist, it's going to overwrite the state of the one that you're merging in. It's going to overwrite whatever one is there at the moment. So you've got that on a relationship. Is that what you want or not? So just look at that. Detach. If you detach, you're going to detach it. Unless there's some, I think it's the same thing as persisting it. If you want to detach the entity, there probably might be reason you might want to detach one of its relationships, but just be careful of that. And then refresh, just go and get all the changes. And I think refresh is also, refresh, get everything you need. So just as an example, so you can have your many to one, you should have your persist on there, and then on your attribute you can go and add your cascade as one of the sort of sub-elements of a one-to-many or many-to-many relationship is there. Just looking at a demo. So what I've got here is I've got my many-to-many on here, which has got for two departures, I've got a cascade, persist, and remove on. On my department, I can do it the other way around as well, and then on my project, if I go and look at my ORM, it's going to add this cascade remove in here as well. This will show what the horrible things that can go wrong with cascade remove doing this. So we've got a cascade remove on the project. So if we remove the employee, we remove the project, we say, listen, cascade down to my employee and remove the employees. But our employees got a cascade remove down to departments as well. So that's going to cascade down to departments. So we're deleting one project, and that's going to delete our database for us.
The sad thing is this actually happens in production.
Yeah. But before we delete stuff, what I just want to do is, so we've got a different grade here. So the first time I created the employees, I used a thing where I actually said manager go and persist the department there, and then go and persist the employees separately. But because I've defined I persist cascade persist on the employee, even if I create a department here and I add it to my employee, even though I'm not persisting my employee, my department, because it's got a cascade on my employee entity to my department relationship, it'll persist my department as well. And I can't remember. Let me just can't raise anything in this database at the moment. Nothing. All right. So what should happen here is that everything should still pretty much work the same as it worked before. So because I've got to persist, I'm persisting my employee. It's going to cascade down to my department. So we go and look at my database here. Let's refresh it. So if I select my employee, we've got our two employees there, and we've got our departments. We're going to look at my department. So even though I didn't specifically persist the department because it's got cascade from employee, it got persisted. And now for the fun part. So it's going delete. I'm going to do it. I'm just going to call remove on my project. So what the remove does is, I very much just go and get all my departments, and then on my manager go and remove all of them. So get all my departments, loop through them, and call manager.remove on them. And that should print out an empty list at the end. So you can see at the end we've got no employees, no projects. So all I did was I deleted the projects, but because I deleted the projects, my database is empty now. There's no department anymore, no employees, no project. So that's sort of how dangerous a remove cascade can be, or cascade remove can be. So just be very careful when doing that. Any questions? No questions. If you've got any questions afterwards, you can also just drop me an email or Rory an email. And I also just want to check and make sure that everybody's got at least one JPA application they've got up and running and have actually played around with it. Because it doesn't really matter for the review quizzes we're doing now, but if you're going to do the certification exam, it's important that you've at least done this and you've played around with it, because otherwise the exam's going to be a nightmare. It'll be much easier to study and learn for this if you've at least got some code up and running. Okay. So this week we've got a review quiz again. One difference though is because we've got the BBD function on Saturday night in Joburg. We're going to close the exam, the review quiz only on Monday night, so that the guys don't have to write the quiz on Sunday with a hangover, because it's probably not going to happen. And I want to keep the average high.
You want to keep the people also.
Yeah, because I don't think you want to write that with a hangover. So it's open until Monday night at 12. Reading for next week, looking at inheritance, which is like a fun thing to do with JPA as well. If you think cascading is awesome, inheritance is even better. And it's probably not, I don't know.
I've never seen that in production.
Yeah, I was going to say, it's probably not something you want to do in production. because I think the DBAs will love you for it. But anyway, so we can look at inheritance and the different strategies and how that works and how JPA is going to create awesome tables for us there. And we're also looking at embedded objects. So a little bit about that. So chapter 4, embedded objects, the whole of chapter, not the whole chapter, chapter 10, looking at inheritance. And then chapter 13, that's just the XML little bits around it. And then section 2.5, 211, and 212 in the specification. So I don't know if you guys are reading the specification, but it's actually not bad. I know it's easier reading than the EJB and the SOAP one. Yeah, much easier. Actually, it actually adds too. I mean, if you read the book and you read the specification, it's almost like they based the book on the specification. Well, they should have, but because of the wording and the way it's structured, it sort of flows together. Okay, I'll upload this demo to Git as well. I don't think I did last week one. I didn't. No, I did. I actually wanted to rename the project, and I didn't. Got lazy. I'm lazy loading it to Git. I'll eager load this one though. Right, so the attendance keyword for this week is relationship. Here's an Urban Dictionary. It's an Urban Dictionary with relationship. So it's if you're like in a bad relationship, but both parties are too lazy to get out of it. And we're just sitting in this relationship. Just staying in this relationship. So it's relationship, singular. Uppercase, lowercase, doesn't matter.
One of the project disasters I've ever heard of have been either lazy loading or cascading, and with an ORM. And that's, and even in here in BBD recently, we won't mention names, but it was because of that.
Yeah, that's
because they don't take the time to actually go and try and understand all of the nuances.
No, yeah, basically not understanding what the ORM is doing, and also if you're not familiar, even let's say you understand how Hibernate works, when you get to a place and they're using Eclipse Link. Eclipse Link might be doing something a bit different, but you don't understand it. You don't actually understand the fact that I'm doing this is going to do that on the database.
And also the underlying implementation of the database, like MySQL versus Derby versus whatever weird.
It's sort of being too far away from the from the road there where the rubber hits the road. You don't always know what's happening, and then you figure that out when you're in production and you start getting volumes. I mean, that's why that's what pretty much I try and avoid ORMs in new systems. Not that ORMs are bad, just from the fact that people use them in a bad way. And you might go and you might set up the best ORM, and its database is awesome, and then you get one guy. Then you get that one guy who brings it down because he didn't understand how it works. And it's just too easy to do that with ORM. It's just so easy. So, you know, that doesn't mean you should be using ORMs. You can use them. Just it's one of those things where I don't want to sound like Spider-Man's uncle.
Well, I'm going to have a blatant plug for Forge, like for scaffolding and prototyping. You can quickly create your own relationship, but with the intention of throwing away the application at the end of it, or revisiting it and taking some time to do it. So that makes sense. Also, when in production, what I find is people do okay, I'll let the ORM create the database and everything, and then I won't let it touch it again or have anything to do with it. So they use it also to generate the initial table structure.
Yeah, so I agree. I mean, as initial creating the database, you can use it, but I found after that, rather do the database stuff yourself and then do the ORM on top of that if you need to, but don't let the ORM go and create the database for you. Don't cascade anything. Don't cascade. Don't use inheritance.
Oh, that's next week.
That's next week.
That's interesting.
I'm saying it's not that ORM is bad, people just use ORM in a bad way.
Well, it's a science. I think it's a discipline. You should have data architects. So I've met one or two data architects who understand ORMs who would write and help you and interrogate your ORM code, though. I met one.
And the other thing is I find like a lot of times there's so much XML in there and it's all over the place. And anyway, all right, enough ranting and raving from this side.
Hey India, hey BBD India.
See if they respond.
Hi.
All right. Anyway, I'm going to stop broadcasting now. Cheers.
Cheers. Bye-bye.
Okay. Rory
said, hey BBD India.
Hi, BBD.
Here's the all 4 people that were on the course initially.
There you go. Hi, guys.
Cricket team.
We're beating the Indians in cricket. South Africa, we're playing again tonight or today. We're playing at the moment. I don't know.
Today we will beat you.